I'm Chris Crosbie. I'm a product manager on databases. I cover a lot of our real-time analytics story and how that relates to various databases. So we do have a variety of things in this space. This talk, I'm really going to be focused on data flow and Bigtable and how they play together, because that is just how a lot of data gets used. You essentially need a state somewhere, and Bigtable tends to be a great state store for a lot of these data flow applications or Beam applications. So you come into Google Cloud, first problem that you gotta have is you gotta pick what database, what's gonna be that state store for Apache Beam. And you have the world of relational databases, non-relational databases, multimodal databases with Spanner. So the first question is, okay, how do I look at the relational database space? So everyone probably knows this. Relational databases, you are storing and providing access to data in tables. It is all very well structured. There's a lot of built-in mechanisms for things like consistency and integrity, and all of that is great. So you can almost think about your relational database as this well-organized library. Everything is very neatly categorized. It's all on the shelf. And the world kind of runs on this approach. So a question that you often get asked is like, hey, what's wrong with this approach? And my answer really is, look, nothing. Like, the world runs on this. If you're doing some kind of Beam application that's going into accounting ledgers or invoices or customer records, great. You know, a relational database is probably the right spot for you. But the right question that you really should ask is you're usually in your state store for a lot of these streaming applications is like, well, what problem do you actually have? And when you get into a lot of these streaming pipelines, you often don't actually have that well-organized, structured information. You have this environment that's more of like this marketplace as opposed to a bookshelf. Stuff is constantly changing. You aren't able to control a lot of times the downstream applications that are feeding into your database infrastructure. A lot of times in IoT specifically, you have these different IoT devices that are changing and different sensor readings, and you really want to go after a flexible and dynamic schema that can handle a lot of that. And that's where this idea of non-relational databases come in, where you can store data, maybe even in with like a single table. You got your keys, you got your values. Sometimes it's JSON, sometimes it's other formats. And this is really the ideal database when you do have these types of data that changes frequently, or you have applications that need to handle a lot of different diverse types of schema. So when we look at, what does a non-relational database typically get you, and this is all non-relational databases, not really specific to Google, but you're going to get requirements around near unlimited scalability. You're going to have high availability, so you can lose nodes and not have to worry about your state going down. You often are able to do really high throughput, combine that with low latency access, and then in addition, you're talking about unstructured or semi-structured data storage, so you really have to handle that flexible schema. And then you typically do the model in a denormalized storage. And then what you get from all of this, and you are making some trade-offs here, but at the end of the day, you often get a much better price performance at scale when you start to look towards these non-relational models. So of course that leads us to our topic, which is Bigtable, which is Google's answer for highly scalable, fully managed NoSQL database. This is what's often used for machine learning and operational analytics, user-facing applications, which are often at the end of these streams here. And so I wanted to share a few. These are all very public examples, so you can go find these. But like, what are folks doing with Beam and Bigtable today? So again, this is all on a blog at X, and all of their ad performance is delivered in real time. So they advertise their dashboards. They need to have about an average of a 1-minute lag between an event when it occurs versus when it actually shows up in a dashboard. And they're okay, and with this a little bit of inaccuracy in the data as long as it's eventually consistent. And so this maps really well to these non-relational use cases. So even though it's analytics, they know in advance the known queries that they're going to provide to their various end users. And so they can pre-computate that, put that into Bigtable, and then pull that very quickly in less than a second. This is essentially what their platform looks like. and they're starting on, they have their ad engagements. It's coming up into PubSub, which gets pulled into their data flow accelerator, and then that goes into what they call their streaming storage, which is Bigtable, and that allows them to get that low, less than a millisecond latency lookups on all of these fresh dashboards. Ford is another company that we worked with who brought us this problem statement of essentially what their issue is they need very low latency because they want to build real-time notifications. They have to know airbag went off, I should know about that now. But they really had a strong need for flexible schema because constantly you have new sensors coming into different cars, you're having over-the-air updates, which is changing the data that's coming to you. And so what they wanted to do is this flexible model. And so they looked at a few different options that make sense here. So MongoDB, that's another NoSQL database, great for a lot of web applications, but essentially it just, heavy use of memory, so it was not very cost efficient when they started to get into these high scale situations. Looked at Postgres, but that obviously is relational, doesn't support that flexible model that they really needed for not controlling these downstream applications. They looked at BigQuery, which is, it's serverless, it's cost effective, but it just didn't have that low latency real-time element that they needed. And then they looked at even front-loading BigQuery with memory store, but memory store couldn't scale. So this is the architecture they ended up going with, which is essentially they send everything first into data flow to do some simple transactions. That's also where there's some rules that exist within Beam that will trigger certain alerts or things that they have to happen right away. And then essentially their core vehicle data store is Bigtable, which lets them do insights via BigQuery, and I'll talk more about how that works, as well as if they needed to do any kind of dashboarding and having that data available long-term, that's all in Bigtable. And they're doing a lot of data. Another example, PayPal. They rebuilt their entire observability platform using a combination of Dataflow and Bigtable. They were on Flink and then moved that over to Dataflow because it was really letting them get out of the business of managing Flink. And they are now doing about 3 petabytes of logs per day, and all of that comes from Dataflow back into Bigtable, which is their historical store there. F-Stream at Flipkart. Flipkart, if you're not familiar, they're an Indian e-commerce company with millions of users, 150 million products, millions of shipments every day. And they have their own in-house streaming platform. There's a state store underneath that the users have to deal, that they don't have to understand how it works. They're just able to call this state store when they need it. And they've migrated from HBase to Bigtable. And the big advantage to doing that for them was they have this $1 billion event. You can think of that sort of like a Prime Day, where they have huge spikes in their workloads, and then being on on Bigtable or in the cloud as opposed to HBase on-prem, they're able to scale that up, scale that down, and they were able to essentially 4x their platform in a short amount of time, and then take that away without constantly paying for it. And so some of those are the examples that have existed for a little while of people who have been running Bigtable with Apache Beam. But we're also seeing a lot of AI and ML workloads recently driving more of these non-relational patterns. Like internally at Google now, DeepMind has been one of our biggest customers internally that have taken off and really been using a lot of Bigtable. And has to do with this flexible schema and the need for that. And so one example of that flexible schema that I'm talking about and why that's relevant for a lot of these AI ML workloads is it comes to these things like a feature store. And I'll walk through an example of where a feature store is oftentimes the end of these streaming applications, how I can get to these online features. So what you're looking at here is YouTube, which is backed by Bigtable for a lot of these feature store applications. And a feature, I think this crowd knows this, but it's essentially anything you're going to use to make some kind of ML prediction. And so on YouTube, you're going to have how many times was this video liked in the last 10 minutes? How many times was it shared in 30 days? Give me a quick analysis of the comments that I can feed in. And then you're going to have a user profile of, okay, how much time do they spend? And then you have your recommendations and how are those recommendations doing? These are all the different kinds of features that might just exist on a single YouTube page. And so typically what happens is you start with a bunch of batch features. These are things like, well, Chris likes cat videos, or whatever it might be. Those are the kinds of things, the features that will go feed into that model. And you might have thousands of these different features that might need to be different flexible columns that exist to go make these predictions. But then often what you're going to want to do is you augment that with a lot of these real-time streaming features coming in, maybe from something like Beam. And then you need to respond to also, okay, Chris likes cat videos, but right now he's at the beach, or right now it's raining, or right now it's the morning versus the evening, and you're going to make different recommendations based on that real-time data. And that's all well and good, but then what happens is all of this is typically not done by one team. You have a lot of different teams all working on the same feature store, and so you really need something that has a lot of flexibility in that schema, and you need controls around that where different people can contribute to different parts of all the same table or all the same user profiles. And so when I look at a feature store, generally there's two different modes that you go into. You'll have these online modes that are focused on right now, like give me that prediction. You want short-term retention, so you want things like TTL to get rid of the old data that you don't need. You want the real-time statistics, and you want that very fast retrieval, because there's a user sitting at a website, and you have to respond or give them a prediction about what they should go purchase next. But you also wanted to build those batch features, so there's often this offline mode where you have historical data that you need for training, and you want long-term storage done pretty cheaply, or batch processing. And you might want to mix a lot of different sources within that for your batch features. So some of the things that Bigtable is built specifically to address that feature store need is, one is we have a feature called Data Boost. This helps you really unify that batch and real-time processing. Essentially what you can do with Data Boost is you can go around the Bigtable cluster, go directly to our storage layer, and then you have a serverless access to the storage. And then you can access that by Beam or BigQuery or other analytical tools. And you can kind of do the same thing that you would do in your analytics. You can do your joins to other BigQuery tables. You can do your processing in Dataflow, and you don't impact that production cluster. Also, this is just a one-time job. It's all serverless model, so you only pay for what you use, and then it shuts down the second that you no longer are running that job. And it's all designed for high throughput, as opposed to Bigtable's normal model, which is point lookups and getting to a specific key. Now, for the real-time mode, when I do have that online store, there are also the ability to do counters, which are distributed counters. This is essentially, you can think about it as a aggregation on write. And so this comes in handy where I'm building features that are something like, okay, I'm right now on your website, and I've looked at now 4 things related to hiking. I want to now feed the prediction that says, show Chris some hiking boots. Things like that. Or a lot of times A/B testing, engagements, impressions, the likes on YouTube, you can think about that as counters. The flip side to counters is there's also continuous materialized views. Materialized views, if you're not familiar with that idea of a materialized view, essentially you can give it a SQL query, and then it will automatically create a copy of the data based on that SQL query that's always running. And these are continuous, as opposed to a materialized view you might be familiar with in other systems that become more of a batch process, where you're rescanning the same data over and over. The way these ones work is they are much more designed around these fresh data streaming type use cases, where the data lands in the source table, and as soon as that data is written, it will push into a shuffle state, just that, it's all incremental, one row at a time, and then you're actually pushing your way through. Then if you have multiple different output tables or materialized views on top of that same source table, it can reuse that same shuffle table. So it is pretty efficient to do that. And again, it's all incrementally updating. You're not going to have the big batch processes, that kind of thing. So that matches really well to piecing up with Beam. And so a lot of customers now are using Bigtable as the full end-to-end feature store, because it supports both this offline and online mode. And Beam really comes in here with a lot of customers and fits in multiple parts of the stack. So for both the streaming ingest directly into Bigtable, as well as looking at the other side via Data Boost and being able to do this model retraining and other analytics on top of Bigtable via Data Boost. Discord's just an example of another public customer that we have that's built their feature store on top of Feast, which is a basically a feature store framework that can use Bigtable as an online platform. Spotify this year at GCP Next was another customer that talked in detail about how they've been using all of their recommendations with Bigtable as the feature store, and all the feature transformations are done in Dataflow and Beam, and then they come into Bigtable in real time, and that's how they're served online. So I will end on just a couple of the specialized capabilities that we do have for Beam and Bigtable, and some of the work we've done to bring these products closer together because they are used pretty heavily together. One is, if it's not obvious, there is a Bigtable I/O. It's now, I think it's in the multi-petabytes per day of bringing in data directly into Bigtable, so it's very production ready. A lot of people using it at really large scale. And we've tried to make it easier with a lot of Bigtable templates. So if you go into the templates, you should be able to get started very easily with continuous options, sync options, as well as source options. There's also an integration for enrichment. So this is very common in these feature store type scenarios where you can think about, you have fraud detection or purchase history. And in real time, you need to go check something from Beam against an entire history or a profile. And what this is doing, this is done heavily already, but with this new enrichment capability, it lets you do this with just, actually on the next slide here, it's pretty, couple lines of code. And so what this lets you do is focus on the what do I want to go pull, as opposed to how do I need to go do that, how do I need to do back off, all that kind of stuff. That's all abstracted, and you can just do this directly from Beam. And finally, there was another talk on this, so I don't want to get too much, I'll just touch on this briefly, but also there are new ML transforms where a lot of people that are now doing vector searches and things within Bigtable. And you need to do this batch load, or if you wanted to use a model that's local to Beam, this is a great way to do it. Again, this is not something you couldn't do in Beam previously. It's just more about making it a lot more consumable, a lot easier to get started, because we're abstracting and giving you guardrails around, or a guide rather, on how you could go do this, and it just kind of works. So with that, I will leave you with my email. It should be easy to remember. It's just bigchris@Google. So if you want to talk about anything in real-time analytics and databases, it's bigchris@google.com.